11 and belong to the physics. So first topic here, what is electric current? So what is electric current? So electric current basically what is flow of a electric charge in a given time in a wire. So flow of a charge in any wires or any material we called electric current. So electric current divided into two types. This type are, first is what is AC and second what is DC. So what is AC and DC here? So AC what is here? Alternating current, and DC here what is? Direct current. So in direct current, value of the electric current with respect to time does not change, while in alternating current, value of the electric current change with respect to time. So these are the some applications where we are electric current. So this is a electric bulb which are glow under the effect of the electrons. When electrons flow, then electric current starts and electric bulb start glowing and radiate energy. So these are transmission lines which are used to carry the electric current from one place to other place. So again, what is electric current and its SI unit? So we know electric current is defined as directional flow. What is directional flow of a electric charge in a conductor? So first of all, what is here electric charge? So electric charge, what is electric charge? Like electrons. So these electrons are basically in metals. Like what is ions? Like NaC positive and Cl negative. So these are ions, and basically what is positive charge? That is holes. So these are known as the charge carrier, and these charge carrier flow in a materials, then it produce electric current. So basically electrons found in metals, and second ions found in ionic compound like NaCl, and positive charge like hole, they found in semiconductor. So these are also again positive charge particle and having charge equal to electron but in opposite direction. And what is the charge on electron? So charge on electron 1.6 10 raised to power 19 coulomb. So here what is coulomb? Coulomb is the unit of a charge. So it is given by the rate of flow of electric charge. So this is another definition of a electric current. And formula of electric current given by charge per time. What is charge per unit time? So this is equal to I is equal to Q upon T, and unit of a Q is coulomb. What is coulomb? And unit of a time is second. So I is equal to Q by T, or this is equal to coulomb per second. So this coulomb per second known as ampere. So this unit on the name of the scientist. So this ampere also known as what is coulomb per second. What is coulomb per second? So this is discovered by Andre Marie Ampere in 1775 and 1886, and we also define what is 1 ampere. So simply what is 1 ampere? 1 ampere simply flow of a charge of a 1 coulomb in a 1 second. What is 1 coulomb charge per second? So this is equal to 1 ampere. So small quantity like of a current are expressed in milliampere. So 1 milliampere is equal to 10 to the power 3 ampere. So and 1 microampere is equal to 10 to the power 6 ampere. So this is known as the microampere. So this is the about the what is electric current and what is SI unit of a electric current, and after which device used to measure the electric current. So basically two type of a device used. So first is what is ammeter, and second is what is galvanometer. So second what is galvanometer. So this is another device used to measure the electric current. Difference between the ammeter and galvanometer, what is? Ammeter measure the large quantity of the electric current in ampere, while galvanometer measure small quantity of the electric current. So in next slide, what are the different type of the charge carrier? What is different type of the charge carrier in different materials? So first is charge carrier in a metals. So there are different type of the charge carriers. So there are, first of all, we discuss about metal. So metal examples of a metals are silver, iron, copper and gold. So there are many other metals like iron and other like nickel and chromium. So these are the type of the metal, and these basically consist what is electrons. So these metal consist electrons. So basically what is electrons? So electrons are the small particles inside the atom. When these electrons are flow, then produce electric current. So flow under the effect of a applied voltage. So what is, when you apply voltage, so voltage what happen? So voltage apply force on a electron, and this charge carrier move in a particular direction. So this is due to the free charge carrier or a free ions. Like an ionic solid contains ions or charge carrier. Ions, what is? Positive and negative ions. What is? Positive and negative ions. And what is positive and negative ions? For example, Na positive, Cl negative, SO4 negative. So these are the ions present in the solution, and when these ions are flow, and these produce electric current. Second, charge carrier in a semiconductor. So semiconductor is the another materials which consist property between the metal and the insulator. So this contain two type of the charge carrier. First is what is negative electric charge, and second what is positive charge. So negative electric charge, what is? These are electrons. So these are electrons. And second, positive charge. This positive charge known as what is? Hole. So semiconductor consists two type of charge carrier, electrons plus holes. Okay, and third type, what is charge carrier in a gas? So in gases, what is charge carrier? There is negative ions present, and what is? Electrons. So these are the different type of the materials, and different type of the charge carrier consist by the different materials. So in next slide, we discuss about the electric potential difference. So what is electric potential difference? Electric potential difference between 2 points is an electric circuit carrying a some current. So some current as the work done to move a unit charge from one point to other point. So what is unit charge from one point to other point? So what is formula? This formula is given by work done upon charge. So what is W by Q? So what is unit of a work done? Unit of a work done, what is? Joule, and unit of a charge is coulomb. So this known as the joule per coulomb, and this is equal to volt. So SI unit of a electric potential known as volt, and electric potential have many names like voltage difference, voltage, electric potential. These are all same. The SI unit of electric potential difference already tell. This is what is volt, and name after the Alessandro Volta on the name of the scientist. Next, so this already we discussed about the 1 volt is equal to 1 joule per coulomb. So this is equal to 1 volt per 1 joule per coulomb. So 1 volt is the potential difference between 2 points in a current carrying conductor. 1 joule of a work is done to move charge of a 1 coulomb from one point to another point. For example, this is an electric circuit. So this is an electric circuit, and this is electric bulb. And this is a metal wire. And this is what is electric cell. This electric cell consists two terminals. What is this? Positive terminals, and this is negative terminals. So what here? positive terminals applied force on the electrons. So there are electrons, these are electrons present in wire. So here this positive and apply force on electrons. So here this is negative and this is positive. Negative and apply force on electrons. This is negative and this is positive. These are electrons are attracted by positive end. Okay. So what is mechanism here? Electric cell apply force on electron. These electrons move in a wire and produce electric current. Okay. So here what is negative, because electron consists negative charge. Negative charge. What is 1.6 10 raised to power 19 coulomb. So negative charge carrier repel and comes to the positive end and electron generate electric current. Okay. So this is the mechanism of a electric current flowing into a wire. So next, what is the potential difference is measured by an instrument, voltmeter. So here which type of device used? We use voltmeter. So voltmeter used to and always connected in parallel. Always connected in parallel. So for example, if we use here here we connect, this is a voltmeter. So this is a device, electric bulb, and this is voltmeter. So voltmeter always connected with a device and this must be in parallel. So voltmeter measure the voltage. What is? Measure the voltage used by the device. Okay. For example, here we use 20 volt. So they may be, for example, this electric bulb use 10 volt. So this voltmeter gives the exact reading of the voltage. So in next slide, these are the different type of the symbol. These are an electric cell. So electric cell, this is the symbol of electric cell. So electric cell consists two terminals. This is a positive terminal. So big terminals known as positive and this is small. So this is negative. When we connected many electric cell, for example, this first electric cell, this is 2-end cell and this is third cell. So many cell connected in a series, they form what is battery and this is switch. So switch simply is a on-off switch. For example, we use in daily life in electrical board on-off switch, like they have open or a close. So how to show? If there are no dot. So this is what is open. If there are present dot, so this is what is closed. And this show the wire joint and this show the crossing of the without joining, and this is electric bulb symbol. And this is what is symbol of a resistor. And what is resistor? We discuss later. What is resistor? Resistor is basically a obstruction produced by the wire. Okay, so zigzag wire known as what is resistor symbol, and there are the two type of a resistor. First is variable resistance and second is fixed resistance. So fixed resistance value does not change, while variable resistance we can change value. For example, 10 ohm to 100 kilo ohm. So we vary the value of a resistance of this device. And this is what is ammeter, already know. So what is the use of a ammeter? Ammeter used to measure the electric current. And finally, what is this is voltmeter, used to measure the voltage, and this is the symbol of a ammeter and voltmeter. So next slide, so we discuss about the electric current. We discuss about the electric current and voltage. So next is what is Ohm's law. So Ohm's law, so this is given by the George Simon Ohm. So this is the scientist name who give this law, and this give the relationship between the voltage and electric current. So he give law, when we apply potential across a wire, then electric current produced. If we change the voltage, then electric current also change. If we increase the electric voltage, then electric current also increase. And second, if we decrease the voltage, electric current also decrease. So we can say that electric current is directly proportional to the voltage. So this is flowing in a metal wire, current flowing in a metal wire, and potential difference across its terminals. So the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional. What is? Directly proportional to the current flowing through it or flowing through a wire, provided its temperature remain constant. So what is here? So this is what is temperature. So this is important because if we change the temperature, then value of a electric current change. So when we do experiment of a Ohm's law, so we fix the physical conditions. So what is physical conditions? Physical condition like temperature. First is temperature, humidity, magnetic field. So these are the physical condition. If we vary the physical condition, then electric current also change. So for accuracy of the experiment, we fix these temperature and other physical condition. So next slide we show, this is the graph between the potential difference and electric current. So when we change potential difference, then electric current also increase. So this relationship shown by the straight line. What is? Straight line. So this show the linear shifts, linear relationship between voltage and current. And according to definition, voltage directly proportional I, or V by I is equal to constant. So we can write constant is equal to R. So what is R here? R is the electrical resistance and is known as the constant, known as electrical resistance So what is electrical resistance? Which produce opposition to the flow of a electric charge. So they decrease the speed of the electrons by applying the force. So these are force depending upon the atomic structure of the materials. So R is constant for the metallic wire at a given temperature and is called resistance. And definition of a resistance, it is the property, what is property of a conductor to resist the flow of a charge, and SI unit is what is ohm. So this is the unit of a resistance. So again, this is on the name of the scientist. What is name of the scientist? Next, resistance of a conductor depends on. If we know already, resistance is the property of the conductor, and what parameter or what factor on which it depends. So first is what is depend upon the length. So for example, we take this wire and we take this wire. So this wire what is AB and this wire what is CD. So which have higher resistance? So AB have higher resistance. Because length of a AB wire is greater than CD wire. Again, if we take, this is a copper wire and similar, this is another copper wire 1 and copper wire 2. So which have higher resistance? So we know here on its area of a cross section end. So resistance is what is inversely. Here what is inversely? Inversely proportional to area. So if we increase area, then what is R inversely proportional L. So R inversely proportional 1 by A. So if area increase, resistance decrease, because here charge carriers, these are the charge carriers electrons, and these are the charge carriers. For example, here 6 charge carriers, 6 electrons, and here also 6 electrons. So here area is large, so electron flow easily in this area is large. For example, like a street, if 100 people moving in a street, in a line, if we increase the area of a street, what happens? They are easily moved. So like that, if we increase the area of a cross section, what happens? Resistance decrease. But here what is R directly proportional to L. So resistance depend only on the shape of the wire, two factor, length and area. But another factor, for example, if we take temperature, if we increase the temperature, resistance of a wire, what happen? Increase. If resistance of a wire increase, then electric current decrease. So here question is, why resistance of wire increase when we increase the temperature? So here answer is, when we increase the temperature, what happen? Collision of the charge carrier increase, because when you heat the electric rod, then charge carrier gain kinetic energy and they becomes fast moving. If they becomes fast moving, what happen? Collision rate increase. If collision rate increase, speed of the electron slow, and speed of the electron slow, ultimately what is? Resistance increase. If resistance increase, current decrease. And so these two factors also write in the form of a definition, directly proportional to its length and inversely proportional to the area of a cross section. So again, this is same as this. R directly proportional to L, inversely proportional to 1 by A. R directly proportional L by A. R is equal to rho L by A. So here, what is important? What is rho? So what is rho? Rho is the electrical resistivity. What is electrical resistivity of the material? So this is the constant of the proportionality, and another parameter which depend upon the type of the material. So every materials have different resistivity. So we study about the next slide. For example, so these are the materials given, these are the conductor. So already know what is conductor, which carries free electron. What is free electrons? So these are known as the conductors. So example of like these are all metals. So example of a conductor. So basically they consist free electrons. When we applied voltage, then the charge carriers flow. So what is the resistivity of a silver? Resistivity silver of a 1.6 10 raised to power minus 8 ohm meter. So this is the unit of a resistivity. Unit of resistivity. And second, what is copper? So copper resistivity have 1.62 10 raised to power minus 8 ohm. So from this table, we found that best conductor is what is silver. From this table, best conductor is silver. So after that, next is what is copper, aluminum, and etc. So these are the metals, but best conductor is silver. So here question arises, why we cannot use silver for the wiring? So answer is because silver is costly. So we cannot use silver. So copper is less costly and cheaply available. So we use copper. And another is what is alloy. So here example, what is alloy? That is combination of metal and metal non-metal. So these are like different example of a alloy. Nichrome like alloy of a nickel, chromium and the manganese and the iron. So what is the advantage of a alloy? Alloys have high melting point and have high resistance as compared to the metals, and they are not oxidized easily. So what is the resistivity? 44 into 10 to the power 6 minus 6 ohm meter. And another what is insulator. So insulator, already know what is insulator. So insulator what is? Bad conductor of electric current. So what is bad conductor of electric current? Because they consist electrons, but these electrons are not free. So here electrons are not free. So when we apply voltage, these electron does not flow. So that is why they are called insulator. So next slide, this is the combination of a resistor in series and parallel. This is combination what is in series. So here three resistors are connected in series, R1, R2, R3, and these are voltmeter. And if what is the net formula of these resistance? What is R1 plus R2 plus R3? For example, this value 1 ohm, and this also 1 ohm, and this also 1 ohm. So what is total resistance? R3 is equal to 1 plus 1 plus 1 is equal to 3 ohm. So we can find out equivalent resistance of any circuit by using this formula. And next, this is resistance connected in parallel. So what is the formula in parallel? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And next, what is heating effect of a electric current? So what is the basically heating effect? When you pass electric current into a wire, then it produces heat. So here question arises, why this heat produced? So this heat produced because when you heat, then electron gain kinetic energy from the heats, and they are fast moving, and collision rates increase. If collision rates increase, they produce heats. Okay, next slides discuss in